Welcome back, everyone. We are going to finish up the Day 8 notes, solving by factoring, and ZPP. Remember ZPP for zero product property. Zero product property basically tells us if any two things multiply together to be zero, then either the first one equals zero, the second one equals zero, or both. And that's what we're going to use to solve. The key word that we're seeing today is the word solve. When you have the word solve, you know your answer needs to look like x equals a number. You have not completed the problem until you get to the point where x equals a number. The method that we're using to solve is factoring, and we've done our 5 factoring methods already. We're just putting those all together now and saying that we're going to solve by factoring. And the thing that we find, remember, when we solve by factoring is the x-intercepts, also called the roots, also called the zeros, also called the solutions. So any of those words could be used in the quiz or in the quizzes or in your homework or next year when you take math again. You need to be prepared to see any of these words. All right, we made it through the first 3 problems in the first video. We're going to do 3 problems in this video, and then I'm going to let you guys work on your Delta math for today. So I look at this one. I notice that it's already in the right form. It's already got equal to 0, so I don't need to do a step where I get 0 by itself. I am going to look for a GCF, and when I look at this one, I realize that x squared and 25, the only thing they have in common is 1. Don't need to factor out a 1, so I'm going to go to factor. Okay, so now think about what we have here and which of our 5 factoring methods this is going to go with. I have an understood 1 right here. 1 is a perfect square number. 25 that I have right here is a perfect square number, and I have minus in the middle, so this is a difference of squares problem. And remember, we had 2 different ways to do difference of squares. We could do it with the AC method, where we put in that 0 in the center, and we do AC. A is 1, C is negative 25. Multiply those together, we get negative 25, so the 2 numbers I want to substitute in are negative 5 and 5. So I'll put those in there. All right, and then we're going to cut this one in half. Factor each side separately. On the first side, I see that I have a GCF of x plus 5 left in the parentheses. On the second one, I can see that I have a GCF of 5, and I'm going to need that to be negative 5 so that my signs will match. Negative 25 divided by negative 5 is positive 5. So now what I have in the parentheses matches, x plus 5. And what's outside the parentheses, x minus 5. And remember we said if you wanted to, for those difference of squares problems, if you wanted to, if you recognize the pattern, that you can go directly from this to this and skip the steps in the middle, and that's okay as well. All right, I need to go back and add in my equals 0. I forgot to write that. Let me put that in there. Okay, so now that I have it factored, now I'm ready to use my zero product property. My zero product property says either this first one has to be equal to 0, or the second one has to be equal to 0, or maybe both. So for that first one, I'm going to subtract 5 from both sides to get x by itself. The directions said solve, so I'm trying to get x by itself so I can solve. And when I do that, what I'm finding is the x-intercepts. So I want to make sure that I write my answer as an ordered pair. Let me highlight that over there before I forget. Write that as an ordered pair. So negative 5, 0, and 5, 0. And then remember what we said when we put that into Desmos, that negative 5, 0 and that positive 5, 0 work out to be our x-intercepts, our solutions, our roots, our zeros, but that is what we have right here. So this ties back together with the graphing that we were doing in the last section. Okay, let's do this one. We have not done one like this using 4 terms, but we're going to use this same series of 4 steps over here. First, our GCF. Okay, well, I look across at all 4 of those. The only thing they have in common is 1. No reason to factor out a 1. So when I have 4 terms, I don't need to use AC. The only reason for AC is to turn something with 3 terms, turns a trinomial into something with 4 terms. Well, I already have 4 terms. So I'm going to go ahead and cut it in half right there. And then I'm ready to do the GCF of both sides. So for those first two, the GCF a little bit different this time is going to be x squared. I always pick my lowest exponent, remember, and the lowest between 3 and 2 is 2. And then what I have left, when I factor that out, x to the first, 3 minus 2 is 1, plus 2. 2 minus 2 on the exponents there, x to the 0 becomes 1, and we don't need it anymore, because 2 times 1 is just 2. All right, and then I look at these two. The GCF of these two is 4, but I notice that the signs on these two and the signs on these two are opposite, so I need to factor out a negative 4. And then what I have left in parentheses is x plus 2. Okay, so I've got my x plus 2 on both of those. I'm going to write those together. Let me put my equal 0 on there. Get a little more space here. My equal 0 isn't going to fit right there. All right, so I've got my x plus 2, and then what I have in the other parentheses is x squared minus 4. Okay, this is a little bit different. This one is linear. This one has x to the first, which is what I wanted, but this one has x squared. All right, well, this one's not linear. So I'm going to check and see if I can factor this one again. Well, sure enough, I have a understood 1 right here, and I have a 4 right here. 1 and 4 are both perfect square numbers, and I see a negative in the middle, so that's difference of squares. I can factor that one again. This time I'm just going to go straight to the pattern. Okay, so according to my pattern, I should have an x and a 2. Sorry, I'm going to have a little bit less space here. And then remember, the signs in the parentheses are opposite one another. So I have a plus 2 and a minus 2. All right, so that takes care of my factoring step. I had a little bit of extra work to do on this one because that factor was quadratic and had to be factored again. All right, now I'm ready to use my zero product property. Well, when I set them equal to 0, I noticed that these two are the same. There's no reason to set that equal to 0 twice. So I'm just going to do that one time, x plus 2 equals 0. And then I'm going to pick up that third one, x minus 2 equals 0. Sometimes these will work out to be the same like this one, sometimes not. This one could easily have been x plus 3 and then x plus 2 and x minus 2. And if that were true, then I would have to have 3 things equal to 0 right here. But in this case, because those are the same, I only have to write it one time. All right, so let's solve. The directions said solve. That means I need to get x by itself. Oh, my little box moved. There we go. So x equals negative 2. Add 2 to both sides on this one. X equals positive 2. All right, so now I'm ready to write my answer as an ordered pair. So this first one, the ordered pair is negative 2, 0. And this one, the ordered pair is 2, 0. So remember what we find when we do this is we find our x-intercept. So here's negative 2, 0, and here's 2, 0. And remember we had two x plus 2's. This is going to be really important when we get to the polynomial chapter. Those two x plus 2's, that gives me this one, which you can see turns, and the 1x minus 2 gives me this one, which you can see cuts through. So a lot of this is going to start coming together in the next couple sections. You can also see that because this one was an x to the third to start with, it didn't make a U shape. It made this kind of squiggly shape. X to the third looks like that. So here are our two x-intercepts, which match with the solutions that we found when we factored. Okay, let's do this last one. I went to the second page of Miss Idstein's notes and I picked up this difference of squares problem because there was something special that I wanted to show you guys about this one. All right, so I see that it does not equal 0. So the first thing I need to do is subtract 4 from both sides. So I've got 36x squared minus 4 equals 0. Okay, now let's go through our 4 steps. First step is GCF. 36 and 4. Well, this one does have a GCF. The GCF is going to be 4. So I'm going to factor out a 4. 36 divided by 4 is 9. 4 divided by 4 is 1. All right, and then I'm going to factor what I have here in the parentheses after I have done my GCF. Now remember, we've been practicing this. This 4 that's on the outside, it just comes down. It doesn't affect what I have right here. Okay, well, I can see that I have 9, which is a perfect square number, and 1, which is a perfect square number. So I can either do the AC method and multiply 9 times -1, get -9. My two factors are 3 and -3 because I remember that I have that 0 in the middle. I can put in there if I want to, and +3 and -3 will give me 0. I can do that process, or I can just do the pattern. Well, the thing that squares to be 9 is 3. So I'm going to need a 3x in both of my parentheses. The thing that squares to be 1 is 1. And then the signs in the parentheses are opposites. This one is plus, and this one is minus. Okay, I have this one is linear. This one is linear. I have factored as far as I can factor. So now I'm ready for the ZPP, ready to do that zero product property. Okay, now think about this for just a second. Does 4 equal 0? Well, no, it doesn't. So when we do our zero product property, we do not set this one equal to 0 because it doesn't have an x in it. It's only the things with the x's that we set equal to 0. 4 does not equal 0, so we don't write that down. We write 3x plus 1 equals 0, and we also write 3x minus 1 equals 0. Now, I'm not telling you never put the GCF equal to 0. Remember when we did, let me see if I can find it up here. When we did this one, the GCF had an x in it, and so we set x equal to 0. The only reason we're not on this one is because the GCF is just a number. It does not have a variable with it. Everything that has a variable has to set equal to 0. Okay, so I'm going to solve each of these. Subtract 1 from both sides on this one. Divide by 3. On the second one, I'm going to add 1 to both sides and divide by 3. All right, so now that I have that, I'm ready to write my answer as an ordered pair. So the ordered pair for this first one is going to be -1/3, 0, and my ordered pair for this one is going to be +1/3, 0. All right, and here's the graph. Had to zoom in a little bit, but there you can see -3 repeating, that's -1/3, and +3 repeating, that's +1/3. And if you think about what we did with the graphing before, when A was bigger than 1, that was a vertical stretch and it made it skinny. So y'all can see how skinny this one is. In order to get that 36 as A, this one turned out to be really, really skinny. So there's my zeros, my roots, my solutions, my x-intercepts, -1/3, 0, and 1/3, 0. All right, at this point, we have finished the videos for today. You guys can go do your Delta Math, and then you're ready to do the quizzes and then the quiz. Be sure you do the quizzes first to practice before you attempt to do the quiz. Miss McHugh wrote both the quizzes and the quiz, and so you need to practice with the vocabulary and the way that she wrote things so that you'll be prepared.